And there we go. Great, the recording is started. Okay, off you go, Trevor.
Okay, thank you for joining us and good afternoon. So I'm from University of Salford, where I head the Acoustics Research Centre here, but I work on both the Cadenza and Clarity projects. And you'll see as I talk about them why we kind of lump these two things together, because they've got a lot of similarities to them. And I'll introduce the other two as we go through. So the kind of aim of this, we started off with a Padlet, just for people coming in to ask questions about what do they want answering. But the idea is I'm going to introduce the two projects. Alinka Greasley, who headed up the Hearing Aids for Music project, is going to come in there. I'm going to talk about why a challenge methodology is interesting. And then Becky and myself are going to finish up by talking about two challenges, one which is launching February, March next year, and one which is live. And as we go through, feel free to put in the Q&A questions. And obviously at the end of it, we can have a Q&A as well. So the Clarity project, as Chris said, it's a UKRI EPSA project. It involves quite a few different universities where it goes through. But you need to run these things to deal with hearing aids and speech. You also need experts in speech, hearing aids, psychology, computer science, acoustics, all sorts of different areas of expertise involved. It's got quite a busy project website, claritychallenge.org, which I would recommend looking at if you want to know more about the challenges. And then Cadenza Project is the new project, which is, again, a different set of universities. So there are some people on both projects. So Leeds is involved. I didn't mention Nottingham last time, so apologies to them, involved in the projects. And the difference between the two projects is that Clarity is essentially looking at speech and Cadenza is looking at music. There's some other differences there as well. But essentially, they're both trying to use this sort of machine learning methodology, this machine learning challenge methodology to improve how things sound for people with a hearing loss. So they're both about growing community of researchers, speech and music researchers who consider diverse hearing. So if we think about signal processing, you go to a conference like something like ICASP, you'll see vast numbers of papers using machine learning. In fact, 95% of papers there are machine learning. Lots of developments recently of increases of ability in things like automatic speech recognition, speech synthesis. But most of the papers at these sessions will not consider the fact that we all have different hearing. Will not consider the fact that not everyone has so-called normal hearing. So what we're trying to do is open up the community so more people consider this really important issue. So we're trying to grow a community. So one thing I would say is if you know any ways of reaching out to people to try and grow our community, that's one of our main things that we want to do. So we're trying to enable those with a hearing loss to benefit from recent advances in machine learning. And as I said, we've got in speech, we've got the Clarity project, which is about speech and noise. And for music, it's not just hearing aids, it's also on consumer devices, which I'll mention again in a second. So why, I'm sure on this SIG, I don't need to give you all these numbers, but basically we have a lot of people with hearing loss. It's growing, set to double across the world by 2050. It costs a lot of money. These are worldwide figures, $1 trillion. You think about hearing aids as being one of the most common treatments for hearing loss, but they're not taken up and used as much as they can. So if you take a developed country like the UK, typical numbers are about 40%. I think that figure might actually come from America. And why don't people use them? Well, they don't think that they're going to help them, or there's issues around a sign of disability and stuff like that. But if you look worldwide, it's even worse. 17% of people with disabling hearing loss are actually receiving any treatment at all. So trying to improve the performance of these devices so more people use them is an important aim. So Clarity is the project which has been running the longest. It's been running for a couple of years now, nearly 3 years, and that's all about speech and noise. It's about the classic problem of the cocktail party effect. So you're down, I don't know how many people are doing cocktail parties this week, but maybe you're actually down the pub or something, and or maybe you're in your departmental end of Christmas do, and you're trying to pick out the speech from the hubbub around. And so that's a typical key problem that people have with trying to get hearing aids to work. And so what we're trying to do there is improve the intelligibility of speech across hearing aids. Now with music, it's slightly more complicated. I think this is more defined, but we're trying to improve the quality of music for hearing aids in Cadenza. And I'm going to pass now over to Alinka. So Alinka is up at University of Leeds and ran this great project called Hearing Aids for Music, where she looked at the problems hearing aids have with reproducing music. Over to you, Alinka.
Okay, thank you very much, Trevor. So yeah, so just to give a very quick overview of the project, if you move on to the next slide, Trevor. Here were some of the aims of the project to understand how hearing loss and the use of hearing aid technology affect music listening experiences and behaviour, to understand some of the benefits and challenges of listening to music through hearing aids, and to explore the strategies that have been used by audiologists in clinic to address musical needs and to tailor hearing aids in particular ways. And I guess the sort of output of the project, what we wanted to do overall was to produce some guidance to help improve access to music for people with all levels of deafness. So we conducted a series of studies across the last sort of 4 or 5 years. Trevor, if you want to move the slide on, please. Yeah, so just here, sort of a clinical survey. I don't really have time to go into detail about all the methodology, but just to say we've conducted a sort of range of surveys and interviews with both hearing aid users and also audiologists to just find out more, find out how hearing aids are beneficial and then what are the challenges there. And we've included people with all levels of hearing loss within the studies, which included some translation of the materials into British Sign Language so that people with more severe levels of hearing loss could take part. So, overall, we know that hearing loss can negatively affect music perception in various different ways. It can cause pitch perception problems. There could be issues with audibility. Many of the participants talked about the difficulties that they had in hearing lyrics within music, for example, or identifying particular instruments. And many also talked about distortion as well. And they talked about the negative impact that was having on their lives. So a reduction in musical enjoyment, being frustrated that they weren't able to listen in the way that they had previously. Some stopped listening to music or attending concerts, and this sort of gradual disengagement of people with hearing loss was having sort of really negative impacts on mental health and quality of life. Now, the good news is that hearing aids do help. They help to hear out the different elements of music, and lots of our participants, Trevor, if you want to move to the next slide, lots of our participants were talking about an improved ability to hear out melodies and to identify instruments and also to hear lyrics. But they did talk about problems they experienced with the hearing aid technology as well. And I've just got some examples here of those problems. So, the issue of kind of sonic artifacts, so distortion and feedback, so that the additional sort of sounds that that they're hearing through the hearing aids that are not there and present in the auditory stimuli. They talked about poor sound quality of the hearing aids, particularly talking about kind of a tinniness or harshness to the sound, which reduced their pleasure in music listening. And then also sort of loudness, dynamics and compression were often referred to. So it might be that the hearing aids cut music off suddenly if it's loud, or there may be problems with quieter passages, and the sort of compression strategies that are applied don't cope very well with music, which can change in dynamics very rapidly, particularly when we're thinking about classical music. The additional problem with the hearing aid technology that was identified through the project was about how the adaptive functions for speech can actually have a negative impact on music. So in particular, feedback, cancellation, and noise reduction. So where the hearing aid actually thinks that pure tone stimuli in music is feedback, and so suppresses it. And the same thing with the noise reduction, with the hearing aid sort of misidentifying music as noise and then reducing it. So what can happen is that the hearing aid user can have a very sort of mixed experience, where the hearing aid is automatically changing the volume or cutting out or reducing the music in some way. Now, the manufacturers have implemented music programs within hearing aids. We don't know what specifically is happening with the algorithm for those music programs, but what we do know, and this has been shown both in the Hearing Aids for Music project and also in previous research, so that basically participants are using these music programs. Some people get on with them and feel that their musical experience is enhanced. Some people report that they can't tell the difference between the music program and their everyday program. And then we have quite a lot of participants who are saying that the music program doesn't in any way enhance their musical experience. So there's definitely the case that, you know, it really highlights that hearing aids are designed for speech perception and not music perception, and that we need different signal processing strategies for speech and music. And I think that was a starting point of our discussions surrounding how the results of this project could feed in here to the Cadenza project. And on that note, I will hand back to you, Trevor.
Thanks very much, Alinka, for that. It's a great project, well worth looking at the website and there's papers out to read more detail. So I'm going to talk particularly about the challenge methodology that we're going to use to give you a sense of what we're talking about here. And I'm just going to take an example, which is actually a simple task. Let's imagine we're going to try and improve the how a hearing aid works. And in this case, I've just put music on this slide. So the challenge is you set this up where you set some databases, which maybe select a listener's audiogram, selects a piece of music, and then you have a block which the people in the challenge are trying to improve. In this case, trying to improve the yellow block, which is the hearing aid, so it works better for music. So we have original music coming in, we have improved music, and then we have an evaluation block on the right-hand side. And that evaluation block can be a metric. Hacky is a metric for audio quality, or it could actually be a listening panel. And so what you do is you give huge databases of music, you set these up to people and say, go on, make us a better hearing aid. And that's essentially the problem that you're setting up. Now, there's a couple of things that I was kind of asked about just to sort of kind of fit into and just talk about one of the questions. So one of the questions someone was asking was about latency. So one of the things with trying to work on hearing aids, as you saw there, is there's a variety of issues, but one of which, and I've got on the left-hand side, I've got some of the issues there. On the right-hand side, I've got consumer products, because you may have seen in that yellow block that I actually had labeled hearing aid or consumer device. So one of the things about Cadenza is we're actually also looking at consumer devices like headphones, like I'm wearing now. Why is that? Because a lot of music consumed is recorded. And therefore, why not try and improve recorded music? Why not do it on the hearing aid? There's a couple of reasons. One of which is latency, which is asked in the question. If you've got a hearing aid, you have to process it quick enough that you don't get a disparity between what you hear direct from the hearing aid and what goes direct into your ear by the airborne route. And that gives you limitations of tens of milliseconds and how quick you can process. And that gives a limitation to what machine learning you can use. So on Cadenza, talking about latency, we are doing both hearing aids and consumer devices. And when we run hearing aids, we'll have a latency constraint on what people can do. And when we run consumer device, we'll say, do what you like, because this is recorded music. You can use non-causal processing and whatever you like. So there's a difference between Cadenza and Clarity. Clarity is all about hearing aids. It's all about live speech. Cadenza is about recorded and live music as well. So the other thing I want to just kind of mention here is the kind of this kind of use of consumer products, because I think someone was talking about the availability of smartphones and stuff in the Padlet. There's a real opportunity to improve consumer products for people who have a hearing loss who don't have a hearing aid. And as I said in the statistics, there's a large number of people who fall into that sort of category. And it has got many more, it has got different issues around them, but basically consumer products like big headphones are quite desirable, whereas hearing aids tend to be an undesirable thing, which should be made small and fiddly to make them invisible, so you don't need to know people are wearing them. It's a very different draw between these two things, and that's why we're also interested in the Cadenza and looking at consumer products, because I think there's people who will use a consumer-based product who might not use a hearing aid themselves. So just to give you a sense of what the challenge looks like, so there's a lot of work going on before launches, like design the challenge, curating software databases, making recordings, website. There's an awful lot has to go together to put a good challenge together, and we're in the middle of sorting some out at the moment. This is CEC2, which was the Clarity Enhancement Challenge 2, which is literally just finished. And if you want to look on the Clarity website and look at the workshop, and probably today or tomorrow, you'll see a recording of the workshop we ran earlier this week with all the entrants talking about what they did and how they got on. But how that worked was in March, we launched a challenge. And then we release a load of training and development software, which is what people work on to try and make their better yellow block, that better hearing aid. Then just before the deadline, in this case, it was July, we released some evaluation data. So because this is machine learning, we need to make sure there's data used in evaluation, which is not the same as what is used to develop the machine learning algorithms. So we release evaluation data late in the day, and then there's a deadline for submission of entries. So that's typically how a challenge runs. And then we have listening tests. So one of the features of both projects is we're running listening tests, because we know that the metrics used, the objective metrics we can use to evaluate speech intelligibility and music quality, are not up to the task at the moment. So we're running a series of listening tests as well, which is hard work to do. And then at the end of it, you have usually have a workshop, a special session or something. And as I said, we just ran the CEC2 Clarity workshop. I think it was Monday, and you can look that up on the website if you want to know more details. So why the challenge methodology? This is just a series of speech tasks ranging from 1988 to 2011. These are all speech recognition tasks. And basically each task is a different data set. So if you just look at the red data set, what you can basically see in general is that the error rate, this is a word error rate, is going down over the time we're running these challenges. So what we find with challenge methodologies is you start them off, and over time systems get better and better. And this is a really important system for driving improved quality in signal processing. If I take this example, which is from ImageNet, we can see this is again over time 2010 to 2017. You can see the classification errors. So this is a load of images where you have to say that's a dog, this is a plane, or whatever. You can see the error rates dropping. Actually, up this end, we're at the point where it's better than humans in terms of identification. And you can see the input of convolutional neural networks, one of the machine learning techniques, which is the sort of flavor of today. So we're seeing with these sort of challenge methodologies, ways of improving things and ways of driving improvements in signal processing. Why have they happened? Machine learning at scale, big data, raw power in your computer and GPU units, lots of open source software for building systems. And this is one of the reasons we have Clarity and Cadenza, is currently hearing aid systems are proprietary and closed. And so we're trying to open up these systems so there's more people who can actually work on them. So all our software is available open source for people to build upon. But the other important thing is we have benchmarks cases. So people can go, and we already have this with Clarity, people are going back and looking at the first Clarity challenge and are trying it themselves, and they can see how they've done against previous entrants. So these challenges have life after they run, where people keep using the databases and keep driving improved benchmarking, improved performance. And so this is kind of what a challenge methodology is all about. And we've seen it's transformed signal processing. I've just shown you a couple of graphs for speech as an example, and we're trying to do that for speech and music for people with a hearing loss. So we're going to pass over to Becky Voss, who works on the Cadenza challenge here at Salford, and she's going to talk about the first Cadenza challenge, which is in preparation. So we're in that pre-stage where we're madly going around trying to organise things.
Okay, can you hear me all right? Okay, hi, yes, I'm Rebecca Voss at the University of Salford, and also thanks to Gerardo, who's prepared some of these slides. So, oh, next slide, please. So I'm not going to spend much time on this because I think Trevor and Alinka have already covered the motivation of the project. We know that hearing loss is very widespread, and we know that they perform very poorly on music. All these effects, yeah, which affects people's enjoyment of music and also, of course, their quality of life. So, and again, Trevor's kind of covered this already. The aim of the Cadenza project is really just to catalyse the new work to improve the processing of audio for those with hearing loss. And this challenge methodology, I think they've already proven it's worked with Clarity, but there's also been a number of other challenges that have used a similar kind of methodology. So we want to bring together researchers across disciplines, have a kind of more diverse approaches to solving the problem and lower barriers to newcomers who wouldn't perhaps have thought of applying their methods to our problems. Okay, and just a quick sort of introduction to the team on Clarity. We have quite a large team, as I think we've already said, spread across Salford and Leeds and Nottingham and also Sheffield. So a number of us are here today. You've got myself, Trevor and Alinka, but I think I've also seen Bruno and Bill and Gerardo and Scott here as well. So there's a number of us here today. Okay, so the first Cadenza challenge, we're planning to launch it in March 2023. So in 3 months' time, and we're going to include 2 scenarios in this. So the first one is a kind of simpler one where a person is listening to music over headphones, and the second one is listening in a car in the presence of noise. So these are 2 scenarios that we identified as sort of common listening scenarios for people listening to music, recorded music, but we will possibly include more scenarios later, and later we're going to have a Padlet where we ask you to identify scenarios that you think people might be interested in. So the evaluation is going to be by listener panel, but we're also using, next point please Trevor, there we go. We're also using the Hacky metric, the audio quality metric, which I will talk more about in a second. So the first track is the listening over headphones. So this is a hearing impaired person listening to music over headphones. They're not wearing hearing aids, so they're just hearing the music that's coming through the headphones. So we have a kind of music selection algorithm from a large database, and then it will go through this headphone processor and then through this kind of Hacky prediction to predict the audio quality. This is a kind of more detailed explanation of what the participants will actually be required to do. So once they get the music, they'll have to demix it into separate channels, vocal, drums, bass, and other, and then remix it in a sensible way to improve it for the listeners. So we will be using this Hacky metric and then also the listener panel to evaluate it as well. So the listeners are, as I said, are not wearing their hearing aids. So the main thing is kind of demixing it into these VD, B and O channels, and then remixing it to improve the perception of audio quality for the users. And we also, perhaps Alinka might want to say something about this maybe later, we also have quite a lot of work going on to determine what exactly listeners mean by the term audio quality. It's obviously a subjective term, which can be interpreted differently by different people. Okay, and then the track 2, so the first one was the headphones, is the second one is listening in a car in the presence of noise. So in this situation, we have a hearing impaired listener sitting in a car, wearing hearing aids, and listening to recorded music. So it's just a basic hearing aid for this one. We've kept it the same for everybody, but they hear music, which is obviously processed by the car stereo, and it has also the effects of the car acoustically and the noise of the car as well. And participants will have access to the metadata about the noise, so the car speed, but not the actual noise samples themselves. Otherwise, it's just a subtraction. So yeah, again, so the enhancement part will mostly happen in the kind of car stereo block, the sort of left-hand block that says enhancement. And then the evaluation will have the car acoustics applied, go through the hearing aid model. And again, we'll be using this Hacky metric as kind of a base scoring system, and then the listener panel as well. Thank you. I think I said all these things. Yeah, so they're using a basic predefined hearing aid. We're not having individual hearing aids for this part. And the entrance of processing the audio from the car stereo, and we have car noise and impulse responses added. Okay. So then just a little bit about this hacky metric, a quality metric that we're using. It is an intrusive metric, so it has to have the degraded noisy signal and compare that to the clean reference signal. So we'll have this process signal, which will be something that's gone through the car noise or headphone situation and had the kind of enhancement process done to it as well, and then compare that to a clean signal as well. Oh, there we go. So what the participants actually get for the challenge, we don't expect them to make all this themselves. They get a complete working end-to-end baseline system. So if you just run the baseline, it will improve the signal a little bit. So they'll also get music data sets and scenes for training evaluation, because obviously this is a machine learning challenge, as we said. So we need to make sure that there is enough data to realistically apply machine learning algorithms. And they'll also receive information about the listeners. So these are hearing impaired listeners on our panel, and I think Alinka and her team have been very busy getting their audiograms. Okay. And a number of tutorials will be available on the website. So people who have experience in some areas, but not all, will be able to fill in the gaps in their knowledge from the information on the website. The code will be all available on GitHub. I think, as Trevor said, it's going to be open source. It's all based on Python and PyTorch. It's sharing the code base from Clarity. So everything is kind of in the same place together. And every challenge will have its own release of the code. And just a kind of screenshot of what that looks like. So there's different repositories and different bits for every project. So just some key dates for the challenge. The 1st of February, we're doing a beta launch, a kind of soft launch of the challenge with all the software and data sets. And then the proper full launch will be the 1st of March, 2023. In June, there will be the release of the evaluation data as well. And then the competition will close in July. So we'll have, hopefully everyone will submit some audio for evaluation, which is what the listener panel will be listening to, and a draft of their technical report, explaining what wonderful processes they've applied. And then in August, they'll be informed which systems are going forward to the listening test. So if we have too many entrants, we won't be able to make our poor listeners listen to absolutely everything. So we'll have a filtering process to reduce the number, and then the listeners will actually listen to them. And then the reports will be submitted to the Cadenza workshop. And then in the autumn, we'll be holding a Cadenza workshop. Okay, I think that's all I've got to say. Yes, thank you. I'm back to Trevor.
Yeah, I think the one thing which struck me when you were talking about that, thanks very much, Becky, was there's a whole lot of work going on. That Alinka is one of the team, and Bruno was mentioned, and also Scott was mentioned, who are, excuse me, who are working on what is audio quality of music, because we know that hacky is limited in how it behaves. But we wanted to get the challenges going quickly, so we're using it as a first round challenge to get things working. And then later on, we'll bring in, for the second challenges, we'll bring in this great new metric that's being developed in the project, which will be more nuanced about what we need from music. And you can ask Alinka questions about that if you want in the Q&A, and you can bring it in to chat about it, or the others who are on the line as well. So I was going to mention one other challenge, which is, it's actually, this one is live. It's the ICASP Clarity Challenge, which, so the ICASP conference, which is in June next year, has a series of challenges. They run signal processing challenges, and we pitched to have one on clarity, and it's been accepted. And so it's up and running now. There's a very quick turnaround on these signal processing challenges associated with ICASP. I'll look at some dates of why that is at the moment. So just to give you a sense of where it fits into the Clarity project, we have two sets of challenges in Clarity. The first one is about making better hearing aids. So this is where the top ones here is about how can we process hearing aid signals to make it better for speech and noise. And as I said, we've run Enhancement Challenge 1, Enhancement Challenge 2, we literally had the workshop on Monday, and then we're running this signal processing ICASP challenge. For anyone who was involved in KEC 2, the difference here, there's a couple of differences, but one of the differences, we're not just asking for speech intelligibility, we're asking for speech intelligibility and quality. So we're using a couple of metrics to evaluate them. And the best entrance for this challenge will go forward to a special session at ICASP in June. And there will be another enhancement challenge running in 23-24. So one of the things about this challenge methodology is you actually need a series, because we're trying to build a community. You can't just run one and stop. You need to run a series so you build up people interested in it, so then the community can take over and run with it. Alongside these enhancement challenges, we've also got what we call prediction challenges in Clarity. So the various ways of predicting speech intelligibility, there's quite a lot of different metrics. None of them work perfectly. So we're also working to use the data we generate out of all these hearing processing algorithms to make a better speech intelligibility algorithm. So in this case, you're given audio examples and you're given scores from speech intelligibility tests, and you're meant to make a model that connects the two. We've run one prediction challenge in 21-22, and just to say, if you're interested in speech intelligibility prediction, there's going to be a new prediction challenge from Clarity, probably launching February, March next year. We're just discussing why it might slip a couple of months, but that's the plan at the moment, is February, March for next year. So if you're interested in the ICASP challenge, it's live. There's the website. Basically, it's all aiming towards this ICASP in Rhodes in June, and it's kind of like now, so it's kind of live, and you can look at it now on the website and see all the different things that are needed to go into a challenge. To give you the dates, it launched in start of December. We've released we've released all the sort of training data sets, the software and all that kind of stuff, similar to what Becky was implying Cadenza is going to do. That's already out there for this challenge. We will release evaluation and test data in the 1st of Feb. One thing which makes this a bit different to the previous challenges, we're going to have a new evaluation data set based on real recordings. Then we have a quick turnaround because it's got to be all reviewed and dealt with for ICASP. So there's a quick turnaround in February, and then the best 5 teams get invited to submit papers to ICASP and get presented in a special session. So that's that process. If you're interested, please have a look at that now or get in contact. Just to give you a sense of the scenario, it gives you a sense of what Cadenza Clarity is doing. This one is a domestic environment. So there's someone talking in the domestic environment. There's some domestic noise. I've got television and washing machine there. And the person listener here is actually, when someone starts talking, they rotate their head to look at the person. Now, someone asked in the questions how to select the speaker of interest. What we actually do in this challenge is we actually give the machine learning system some recordings of this person talking in clean, not obviously this phrase, but a different phrase. So the machine learning algorithms can actually learn which voice to pick out if there's a speak interferer as well. So again, you can look at the workshops to see how people did that, but there was a variety of sort of kind of take these sort of speaker identity sentences, put them through some network to get some key features, and then feed that into the neural network, which is actually doing the speech enhancement task. So there's a few different techniques have been used there. You could look up for those who asked me that question. This is what our baseline looks like on this. And one of the things we didn't talk about is one of the keys to this is growing communities, is to try and fit into communities who recognize this as a challenge that they can enter. And that's one of the reasons Becky talked about the hearing the headphone case being a demixing task. Partly that's because there's a big community who do demixing work, and therefore we can tap into that community to grow our community. In this particular case for Clarity, we're trying to tap into the speech enhancement community. There's loads and thousands of papers on speech enhancement, most of which do not consider the hearing ability of the listener. So what we've done in this one is we've actually separated out the speech enhancement stage of a hearing aid and the sort of kind of amplification stage of a hearing aid, if I could put it that way. And we will provide this hearing aid. It will be a fixed block. And then people are concentrating purely on this speech enhancement phase. And the reason to do that is because then people who are not confident in hearing loss research, but are confident in speech enhancement, will be able to enter and compete in the challenge. So that's part of the community growing. And as I mentioned before, we're using both intelligibility and quality, HASPI and HASCII, to do this. For ICASP, we don't have time to run the listening test. So this will purely be objective evaluation in this case, a weakness of the process, but that's down to fitting in with the ICASP timing. So we're going to pass over now to a Q&A, but we've also made a Padlet. I don't know if you can paste the URL into the chat as well. So one of our questions we always ask people when we get to talk to them is, what should we do in the future? Because this is meant to be a community project. So we always take feedback and try and feed it into trying to make better challenges in the future. So at our workshop, we had a whole discussion section about ecological validity. So if you're interested, if you go to that second Padlet, feel free to add suggestions about scenarios. So, you know, what you're thinking about, who is doing the listening, where are they doing the listening, what are they listening to, and anything else about the project you think we could improve on if you're aware of it, or things we need to consider, and be delighted to hear. So I think that ends the kind of what we wanted to cover in terms of a talk, and so we can move to a Q&A and some questions about the project.
Already got one.
I think I'll just stop the recording so that people feel like if we do want to have people talking, they can do that and not feel intimidated about that.
Yeah, so we've got a question from Brian